Hello everyone! Now let's dive into the bare metal demo for the P159 radio board. Please follow my steps and you'll quickly get the hang of the entire process. Our bare metal project uses Vivado 2019.1. For testing, please ensure version consistency and open the project with this exact version. Note that other versions may work, but they could cause IP changes, requiring manual adjustments and extra work, so we would prefer to use 2019.1. Once the project is successfully loaded, let's check the block design first. This section primarily contains two core components, the JESD204B interface and MP-SOC parameters. Double-click the MP-SOC module to view its detailed configurations. It comes pre-configured with SD card, QSPI, DDR, and more. Next, open the SDK. Note that for the API functions of the RF chip, ADI officially only provides the API function version now and no longer provides the integrator version. Opening the SDK will auto-re-import the hardware platform. This is normal for copied projects, has no impact on the demo, and can be ignored. Now let's focus on the code for project P159, specifically the main function in headless, C. Let's start with the main function and go through the code logic top to bottom. First, this is the code for configuring the local oscillator. Its configuration is in two places. One is this part of the current headless C file, and the other is an arfconfig C, which we can find by simply searching for the keyword. The following section outlines GPIO configurations, specifically for the RF chip, TX and ARX enable settings, TRX switch configuration, and clock sync pin configuration. Further down is the initialization of our clock chip. Next is the initialization and configuration of our RF chip. Here, we can see that the current TX power is set to -25 decibel milliwatts, which is a preset for the demo, and so on. Finally, there's the configuration for single-tone signal transceiving. After reviewing the code, select Run for online debugging. Version note: Vivado 2019.1 doesn't check the startup mode. We can download directly even if the board is in SD card mode. Higher versions require switching to JTAG mode first. Once the program runs, check the digital log in the serial terminal on the right. The log shows the clock chip is locked and synchronized, the interfaces for TX, ARX, and ORX are locked, the current radio frequency local oscillator of 5.8 GHz is successfully configured and initialized. The log also displays the sampling rate as 245.76 MHz. After the print information is downloaded, we can use a spectrum analyzer and a signal generator to perform actual signal verification. We connect the spectrum analyzer to the transmit end of TX1. On the spectrum analyzer, the displayed frequency is 5.807 GHz, and the actual output power is approximately -5 decibels milliwatt. This is because our preset TX power is -25 decibels milliwatt, plus a gain of 20 decibels. I've set the single-tone signal frequency and output power of the signal generator, respectively, to 5.779 GHz and -35 decibels milliwatt. Next, we'll verify this via the integrated logic analyzer in our Vivado project. We'll use a signal generator to transmit the signal, and the Vivado integrated logic analyze to capture the signals in phase and quadrature data. As you can see, channel 2 has successfully received the signal from the signal generator. Next, right-click on the ILO window. Select Export, save the captured IQ data as a CSV file, and then import the file into MATLAB for further data analysis. Now, the bare metal demo for our P159 radio board is complete.